Hey everyone, and welcome to today's Explainer. If you're gearing up to master HPE Private Cloud AI architecture, you're in exactly the right place. Today, we're breaking down the absolutely critical concepts from the HPE2-B08 exam blueprint, and we're going to approach this exactly the way a master architect tackles a brand new client engagement. We're skipping all the marketing fluff and getting straight into the operational, technical, and architectural decisions that actually make private AI deployments successful. Right off the bat, I want you to think about this statement straight from the certification guidelines. Do not treat every AI performance issue as add more GPUs. Let that sink in for a second. Seriously, throwing more compute at an undefined problem is literally the biggest failure trigger trap you'll see, both on the exam and out there in the real world. A training job might just be blocked by slow storage reads, or maybe an inference service is choking on request concurrency, or a RAG assistant just has a totally stale index. If you just instinctively add GPUs, well, you're just building a very expensive, very fast bottleneck. Okay, let's dive into this. If we aren't just, slapping a high-end GPU into a server and calling it a day, where do we actually start? What's the right consultative framework? Basically, how do we build an evidence-based design instead of making a product-first mistake? Well, here is our roadmap for the architect's journey today. Number 1. Assessing AI customer maturity. 2. Translating needs to constraints. 3. Classifying AI workload patterns. 4. Securing the RAG boundary. And finally, number 5. Infrastructure beyond the GPU. All right, phase 1, assessing AI customer maturity. So before you even think about selecting hardware, you've got to move past a customer's vague ambitions and assess their actual operational readiness. This is absolutely crucial. You literally must check for these 4 maturity anchors. Do they have governed data? Is there a measurable success metric? Who's the workload owner? And who actually owns operational support? A lot of customers will come to you and say, hey, we need AI, but they can't even name the data source or tell you who's going to manage the model updates. Skipping this step is a massive red flag. Honestly, if nobody owns platform health or incident triage, the project is basically doomed before it starts. And if any of those maturity anchors are missing, your next move is simple. Step back. You've got to return to discovery and use case qualification. You do not prematurely size a configuration. A mature customer is going to be able to sit down and discuss security boundaries and data locations. An early customer, they just have a cool business idea. Your job as an architect is to build the evidence you actually need to support HP Private Cloud AI positioning later down the line. Moving right along to phase 2, translating needs to constraints. Once we've got a mature, qualified use case, we take those high-level customer needs and translate them into hard technical constraints. So the crucial point is that private AI isn't just a label for where a server physically sits. It demands strict data and lifecycle boundaries. Say a client tells you, hey, our internal documents have to stay controlled. That translates directly into a data locality and access constraint, which you solve through governance and storage design. Or if they say they have interactive users, well, that translates to latency and concurrency constraints solved by endpoint scaling. If you deploy a solution that solves the wrong constraint, like tossing in more GPUs when they actually needed strict data residency controls, you've completely failed the customer. Next up, phase 3, classifying AI workload patterns. Okay, golden rule for the diagnostic phase right here. You must read the AI verb first. You have to draw a really sharp contrast between your workloads because they absolutely do not stress the platform in the same way. If the verb is train, you're dealing with long epochs, big batch sizes, and massive dataset movement. Your bottleneck is probably going to be storage reads or accelerator memory. But if the verb is serve or infer, you're looking at request queues, latency targets, and endpoint scaling. Think about it. If a training job is starving because of slow storage throughput, adding more endpoint replicas won't do a thing. And if an inference workload is bogged down by concurrency, buying more raw dataset capacity isn't going to fix your latency. Now, what's really interesting here is how easy it is to fall into a fatal design flaw. Mapping an AI label directly to a SKU without identifying the true resource pressure is a huge mistake. Exam distractors are explicitly designed to trick you by throwing out a visible component, like switch capacity or GPU count, while totally ignoring the actual workload bottleneck we just talked about. Always identify the controlling resource path first. Let's pivot over to phase 4, securing the RAG boundary. Let's shift our focus to generative AI for a minute and see how this builds. It is absolutely vital to isolate the foundation model itself from the surrounding retrieval system. Look at the life cycle of a single prompt. A user's question doesn't just bypass everything and go straight to a model. First up, we've got document ingestion into a corpus. Then, step 2, chunking and embedding, which figures out what material is actually available. Step 3 is the vector index refresh. And then finally, at step 4, the serving runtime combines the prompt with that context for model endpoint generation. So as you can see, answer quality starts way before the GPU even gets involved. I really want to emphasize this core priority. A healthy model endpoint does not prove a healthy RAG system. Seriously, if your AI assistant spits out an answer that's incredibly fluent, beautifully formatted, but is just factually wrong or quoting some totally outdated internal policy, your compute capacity is completely fine. Your bottleneck is actually your index freshness, your embedding compatibility, or how you prepared your corpus. The classic trap here is trying to fix bad answer quality by buying more compute, rather than validating the retrieval and lifecycle state. Finally, we're at phase 5, infrastructure beyond the GPU. Notice how we saved the actual hardware conversation for the very end? That is exactly how a true architect operates. When we talk about HPE ProLiant Compute, we have to be clear that a GPU server isn't just about raw capacity. It's an intricately coordinated stack. The underlying compute architecture dictates how multi-GPU scaling works. It controls the memory topology. It manages the absolutely crucial thermal envelopes and power profiles. Basically, a massive top-tier GPU is utterly useless if the server platform beneath it can't power it, keep it cool, or connect it efficiently to other accelerators. And honestly, all that visible hardware is effectively inert without the software layer. That's where NVIDIA AI Enterprise comes in. It provides the supported software runtime, the containers, the drivers, the NIM-style inference services. This is the validated stack that officially bridges the gap between your workload requirements and the raw physical accelerators. Without this layer, your workloads simply can't securely or reliably tap into the acceleration you just paid for. Next up is HPE GreenLake for file storage. Remember our diagnostic phase? A starved GPU is a wasted GPU. If you're trying to feed a massive training pipeline or you're constantly refreshing vector indices for a RAG deployment, your storage throughput is just as important as your processor. Governed high-performance data access is what keeps those incredibly expensive GPUs from just sitting there, twiddling their thumbs, waiting for data reads to catch up. So the key takeaway here, and you'll definitely see exam distractors trying to trick you with lists of isolated, disjointed components, is that you must be able to explain what GPU-enabled HPE compute actually contributes to AI execution. The right answer, the architect's answer, will always connect the infrastructure back to the specific workload bottlenecks we diagnosed earlier. Whether that's memory footprint, dataset locality, or endpoint concurrency, it all has to tie back. Which leaves us with one final, absolutely critical question to ask yourself on literally any private AI engagement. Are you sizing for the hype, or are you sizing for the bottleneck? Remember, true architects aren't just out there selling servers. They diagnose resource pressure, they ensure customer maturity, they lock down data boundaries, and they deploy targeted infrastructure. Keep all of that in mind, and you are going to absolutely crush the HPE2-B08 exam. Thanks so much for joining me on this explainer, and keep learning.